So here we're given a polar equation, r equal negative 3 sine theta plus 1. And we're supposed to find points on 4 rays plus graph it. So first we're going to graph it and then we'll worry about the points on the rays. We're first going to graph this in the rectangular or Cartesian coordinate system, and then we'll use the key points from that to get the polar graph. So looking at this equation, the plus 1 on the end moves the baseline up 1, so it's going to oscillate around y equal 1. And the period, because it's just a sine theta, is going to be 2 pi. So I'm going to make 1, 2, 3. The fourth one will be 2 pi. So the middle will be pi, and half of that will be pi over 2. And this one will be 3 pi over 2. Now we're going to graph sine. So at 0, sine is 0, except it's moved up 1. So it'll be here on the baseline. The amplitude is 3. But the negative makes us go down before we go up. So we need to go down 1, 2, 3. So in that first fourth, we're down here at the minimum. In the next fourth, we cross the baseline. The next fourth, we're up 1, 2, 3 at the maximum, and then cross the baseline again. So the graph looks like this. Now we're going to put that on a polar graph. And so this will be our 0, and this is our pi over 2, pi, and 3 pi over 2. And so we look at 0, and we are at 1. So at 0, we need to be out here 1. At pi halves, we are at negative 1, 2. And so at pi halves, normally we would go up this way, but we need to go negative, so back through the pole by 2. And another thing I notice is this crosses the x-axis, and so that means I'm going to go through the pole because that's where it equals 0. So I need to come around here and go through the pole and then around and end there at pi halves where the r is negative 2. So pi halves, but back through the pole the other way. So that we just graphed was this piece right here on the graph that I'm darkening in. Now we'll do another color for the next piece. So from pi halves to pi, I need to still have a negative r where I start there, but I'm going to go back through the pole, and then I'm going to go to positive r, and at pi I'm going to be at 1. So at pi, I'm going to end up at 1. I'm going to come around, go back through the pole, and end up there at 1. Now looking at the next piece from pi to 3 pi halves, I'm going to be at 1 at pi, and I'm going to be increasing until I get to 4 at 3 pi halves, because it's 1 plus the amplitude of 3. So 3 pi halves, 1, 2, 3, 4, that's going to be down here. So I need to increase, come around, and go through that point. And then our last piece of the graph would be 3 pi halves, we're at 4, and we're going to decrease till we get to 2 pi, and we are at 1. So they're going to come back around like this. And this one is called a limosone with an inner loop. Now let's go ahead and answer our questions. At 0, well, we can look here and see we are at 1. At pi fourths, now I don't have pi fourths calculated here, so I'm going to take the equation and I'm going to put in pi fourths. So negative 3 sine of pi fourths plus 1. So negative 3, the sine of pi fourths is square root of 2 over 2 plus 1. So I'm going to put that in as negative 3 square roots of 2 over 2 plus 1. Now at pi halves, I do have that value here at pi halves. I am at negative 2. And finally, at 3 pi fourths, I'm going to compute that, negative 3 sine of 3 pi fourths plus 1. Now, sine of 3 pi fourths is actually the same as sine of pi fourths, so it's going to be the same answer of negative 3 square roots of 2 over 2 plus 1.